Welcome. Today we'll be discussing some examples in preparation for the test. For example number 1, we have a central angle is pi over 3 radians. The radius is 3.2 miles. How long is the arc? What is the area of the circular sector? So two formulas should be popping out at you when we see a central angle. When I see circular sector, I should think of the formula area of the sector is equal to theta times the radius squared, all divided by 2. Or I could rewrite this as 1/2 times the angle, the central angle, times the radius squared. Okay, well, what about for the arc? Well, that formula would be simply theta times r is equal to the arc length. Okay, so we can perform these calculations and we get L is equal to pi over 3 times 3.2. So we get 3.2 pi over 3. And let's times top and bottom by 30 or by 10. And we get 32 pi over 30. I can simplify this, divide by 2, and we get 16 pi over 15. Now, we might look at this and say, okay, we're done here. However, a real-world question requires a real-world answer. So instead of just ending your calculations here, I would write that the arc length is about 3.35 miles. And that would be my answer to first part. So now for the second part, we want to get the area of the sector. So we can plug in the formula. We have area of the sector is equal to 1/2 times pi over 3 times the radius squared. So that's 3.2 squared. We plug this in our calculator and we're going to get something like 5.36 miles. However, don't end here. Simply put it back into the real world answer and say the area of the circular sector is about 5.36 miles. And this would be a complete answer to question number 1. Question number 2, let's assume theta is acute, use exact answers, find all the trig functions when cosine of theta is equal to 8/11. Okay, so first thing we want to do is draw a picture. So we're going to have some triangle. And we're saying that we have a theta here. And the reason why that we have acute here is because we want to say, hey, we can just make a generic geometric angle here for a triangle. And so when I make this geometric angle, I can now assume a right angle on one side. Here's my theta. Cosine is opposite over hypotenuse. So I'm going to have an 8 here. I'm going to have an 11 here. What is here? Well, we can figure that out and go, all right, 11 squared is, or let's write the hypotenuse squared is equal to leg 1 squared plus leg 2 squared. So we have the hypotenuse, which is 11. We know one of the legs and we don't know the last leg. So we have 11 squared equals 8 squared plus some unknown value. So I'm going to put x squared. Well, 11 squared is 121. 8 squared is 64. And we get still x squared. Subtract 64 to the other side. And we're going to have 57 is equal to x squared. Take the square roots, and we're left with x is equal to square root 57. 57, we can't take any perfect squares out of that, so we're going to leave it like that. Now, how do we find all the other trig identities? Well, the first one we already have, cosine of theta is equal to 8/11. We can take the reciprocal of this, and we have secant of theta is equal to 11/8. Now we can use our triangle. We can input 57 here, or square root of 57. And now we can find the rest and say, okay, sine of theta. Oh, I have this backwards. My apologies. We had cosine. So this should have been 8. And this should have been question mark, which then this is square root of 57. My apologies on that. But I caught myself finally on it. And I'm looking at sine, which is opposite over hypotenuse. So we have square root 57 over 11. So that means that cosecant of theta is equal to 11 over square root of 57. And now we can do tangent theta, which is opposite over adjacent. So we have square root 57 all over 8. And cotangent of theta, which is 8 over square root 57. And there we have the exact values for all of our trig functions. Okay. So now let's take a look at a few more examples. And so example number 3. We're going to let theta be in Q3, in other words, quadrant 3, with a terminal side parallel to the line 4x plus 6y equals 7. Find tangent of the same theta. So first, let's draw a picture of where our angle is. Our angle is somewhere over here. So here is our theta. Okay, well, now we can find the line. Now we want parallel to the line, so we really want the slope of whatever this line is. So let's focus on how we can get that slope. We have 4x minus 6y equaling 7. I'm going to subtract x to the other, 4x to the other side. So negative 6y is equal to 7 minus for x, divide by -6, and I get y is equal to 2/3 x minus 7/6. I don't care about where my line actually is. I could draw it on here, and if I did, my line would be something like something to that effect. It's more like that. But the point is I want the slope. I want my terminal side to match the slope of this line. So the slope is here, which is 2/3. Meaning that if I mark my rise over run, I can scale a triangle. I'm going to pull out a triangle now where my rise is 2, my run is 3, and here's my hypotenuse. And so what's my hypotenuse? Well, that is 2 squared plus 3 squared. So this is equal to square root 2 squared plus 3 squared, which that's 9 plus 4, that is 13. So we get square root 13. Now, where is this? It's in the third quadrant. So I know I have a negative sign and I have a negative cosine. So I can think of this as a -3 and a -2, meaning when I take my tangent of theta is equal to, and the theta is starting, the theta kind of goes from the origin to my terminal angle. So if this point here is -3, -2, I can then think of, here's my rise and run to get back to the origin. Here's my distance is 13 for my hypotenuse. But my opposite, I can think of a -2 for the y, and the adjacent, I can think of -3 for the cosine. And so I have opposite over adjacent, so -2 over -3, which is 2/3. That equals tangent of my theta. Another way that I could think of this is I could form a reference angle. And then with that reference angle, I can find my tangent. Is it positive? Is it negative? Well, what quadrant is it? It's in the third quadrant, so it must be positive. And we get the same result. For the fourth question, let's get rid of both these. So for question number 4, suppose that a triangle is described by angle A, that's what this A hat kind of means. Angle A is 90 degrees, angle C is 30 degrees, B is 30 degrees centimeters, find all missing values. So I'm first going to make my triangle. I have A, B, C, and I know that this is 30 degrees, this is 90 degrees. So angle B, or B hat, is equal to, we're going to have 90 degrees minus 30 degrees, which equals 60 degrees. And that would be our answer. So let's box that in. B hat is equal to 60 degrees. So now we can use different formulas for us. We can start to find the other sides. Where is B? B is 30 centimeters. That's here. This is a special right triangle, a 30, 60, 90. So we could use our known properties. And if we were to do that, we could have this side be equal to x, this side be equal to 2x, and this side be equal to x square root 3. So we have 30 equals x square root 3 divided by square root 3, and we have 30 divided by square root 3 is equal to x. Well, what is x? That's our side length of C. That's our little c. And so then our little a is equal to, and we get 60 square root 3. Now, we have this in terms of a unit, so we can write centimeters. And we'll have C is equal to 30 over square root 3 centimeters. And I would say that this is correct. However, I could also see the argument being that since we defined the units, this is a real world question, which then you would not be wrong to also approximate this to the nearest decimal point, or the nearest tens decimal point, I should say. Okay. So the last question I want to touch on, 5, is we want to describe the following equation: 5x minus 2 squared plus 25y squared equals 629. So when we look at an equation like this, we want to figure out, okay, is this a square? Right now, or sorry, is this a circle? Right now it's kind of a little bit hidden. Let's try to clean this up. Let's make it look, let's see if we can recover a circle. Remember, a circle equation is x minus h squared plus y minus k squared equals r squared, where h and k is the center of the circle and r is the radius of a circle. So here we can go and say, all right, how can we get to here? Well, let's first expand this binomial. So we get 25x squared minus 10x plus 4 plus 25y squared is equal to 629. So I'm going to subtract 4 to the other side. And that leaves us with 625. I'm now going to divide each side by 25, and we get x squared minus 2/5 x plus y squared equals, I'm just going to write 625 divided by 25. If I wanted to simplify this to 25, I could, but if you don't see that, that's okay. We'll address that in a second. So now we have to apply completing the square to the x side. So we have -2, or let's do scratch work, -2/5 x is going to equal -2ax we're going to cancel out the x, divide by -2, and we get 1/5 equals a. So now, when we take this a, we're going to want to square it. So we're going to have x squared minus 2/5 x plus, oh, I made a mistake here. This is supposed to be a 20. This is supposed to be 4. And that's why it was making it a little bit weird. So here's a 4. And this is supposed to be 2/5. Yes. I worked it through earlier and I was just like, why am I getting a different number? Because I had 5x times -2, then times by 2 again. That's what I get for not showing my work. Proof that on the exam, please show all your work. Show every single line. That way, if you make a mistake, we can catch it instead of trying to figure out, okay, where did the mistake come from? And you'll earn more points that way. Looking at this, we have x squared minus 4/5 x plus, and we want to have 2/5 squared, but we're going to subtract the same 2/5 squared, add our y squared, and this is equal to 625 over 25. Okay, I'm going to add this to the other side because I don't want that on this side of the equation. So I'm going to add 4 over 25. How did I get 4 over 25? Well, that's 2/5 squared. That's 4 squared over 5 squared. Or sorry, 2 squared over 5 squared. So I get 4 over 25. On this left-hand side, I can simplify it to x minus 2/5 squared plus y squared equals, and I have 629 over 25. That's why I left it in 25, or left it at 625 over 25. I didn't simplify it. And I want the square of this number. I want r squared. So I have to take the square root of this. And so I'm going to find that this is equal to square it 629 divided by 5. I'm going to take this entire thing and square it. So now what I can do is I can describe my equation and say, I can say it's a circle centered at positive 2/5, 0. Why is it positive 2? Because the h, I have a x minus h, x minus 2/5. I'm just going to take 2/5. And then the 0, well, y minus 0 is just y. So that gives my point centered at 2/5, 0, with a radius of square it 629 over 5. Now, 629 is factored into 17 times 13, so we can't reduce this radical anymore. But the important thing is that I leave it in radical notation, and I'm also going to attach units to the radius because it's a distance. And then the other part of this is I'm not going to estimate it because we're dealing with a math question, so leave it in a math answer. Okay, so those were 5 review questions in preparation for the quiz. Thank you for watching the video and Have a great day.